one of the ways in which nature forces its rules into us as conscious entities is the conservation of mass and energy. Well, mass and energy are equated, as Einstein, I think, discovered. But I would like to know, what is one of the most tricky and sneaky ways in which nature forces conservation of energy ultimately to how much energy you have?
Yeah, so conservation of energy, conservation of momentum, concepts like this are at the absolute cornerstone of our modern understanding of physics. The concept of conservation of momentum, for example, underlies every single theory of physics. And we don't normally think of theories of physics or the formulas that you might have learned or the equations you might have learned as expressing conservation of momentum, but it really is. Like every single physical theory, every modern theory is ultimately derived from basic concepts like conservation of energy and conservation of momentum. So if you think of the wildest situation in physics, if you think of the wildest thing that we observe in nature, like radioactive decay, like the expansion of the universe itself, like the birth and death of stars, all of that is understood through a lens that starts with conservation of momentum and energy.
But there's an exception there. In your book, Your Place in the Universe, you talk in one chapter, I don't remember now which one specifically, about how dark energy doesn't rule itself by the rules of conservation of energy, in that there's a sneaky way in which it's infinite in a sense, expands itself. And so, is there any way we could use this to avoid the eventual heat death of the universe by reversing entropy indefinitely, using the seemingly existing loophole that exists in physics in relation to dark energy, as you mentioned?
So when it comes to dark energy is the observed accelerated expansion of the universe. And one of the curious things about dark energy, which we do not fully understand, we do not know what is causing the accelerated expansion. We have a cool name for it, dark energy. If dark energy is somehow related to the vacuum of space-time, which we suspect it might be, it has this curious property that it accelerates the expansion of the universe. This gives you more universe. The volume of the universe is physically larger, which gives you more dark energy, which causes more acceleration, which gives you more universe, which gives you more dark energy, and so on and so on. So at first glance, it appears to be violating conservation of energy because there is literally more dark energy being created every single day. But we have to be careful with statements about conservation of energy, conservation of momentum, and this is highlighted by the difference between just saying a concept like energy is conserved and actually writing down the mathematical expression of that same concept, which is much more rigorously defined and much more narrowly defined than the natural language words we might use to describe it. So the existence of dark energy and the accelerated expansion of the universe does not violate conservation of energy. You might think it does, but that's because we're using a very limited language, in this case, the English language, to describe the concept. But when we break down the actual mathematics behind it, we see that what's happening is that conservation of energy, as we typically understand it, which is that energy cannot be created or destroyed, only applies in isolated systems. When you have a dynamic evolving system. In this case, we live in a dynamic evolving universe, a universe that is constantly expanding already. You can get situations that appear to be violations of conservation of energy, but when you balance everything up, when you add everything together, when you include the actual dynamics of the system in the mathematics, you see that everything is fine. So dark energy isn't really cheating. It's not really a loophole. And unfortunately, there is no way to put dark energy to any useful amount of work.
God damn it. I thought we had a loophole to solve the heat death of the universe, but it seems like we don't.
Unfortunately, no.
Okay, I will have to keep thinking. Well, not thinking, but I will have to accept nihilism as the correct philosophy.